Today we are going to be looking at simultaneous equations. And I'm going to start with some very simple linear simultaneous equations. So to begin with, let's do an example. We are going to solve the simultaneous equations x plus y equals 11 and x minus 3y equals 7. Now what we usually do here is we will label the equations 1 and 2, and I'm going to do equation 1 minus equation 2. When I do that, I will get x minus x, y minus negative 3y, so that'll be y plus 3y, and 11 minus 7, which tells me that y equals 1. Then I can take y equals 1 and plug it into one of the other equations. So equation 1 now becomes x plus y, which is 1, equals 11, so x equals 10. So that is just a recap of some simple linear simultaneous equations. So I'd now like you as a starter exercise to do question 1 from the exercises that I've put on Show My Homework. So these are the questions that you should be having a go at. So pause the video, then you've got the example there to help you, and you can have a go at these questions. Then once you've had a go, please mark them with the answers that are on Show My Homework, and then carry on watching the video for the next example and next set of questions. So these are the answers you should have got for those questions. Please take a minute to mark them, and then I'm going to go on to the next example. So in our first example, we had simultaneous equations where the coefficient of x were the same in both equations, which made it really easy to do because we could just subtract one from the other. However, if we do an example where the coefficients of x are not the same and the coefficients of y are not the same, we'll have a look at the method we need to use there. So here we've got x coefficients of 5 and 2, y coefficients of negative 4 and 6. I'm going to label them 1 and 2 again. And what I'm going to need to do before I can work with them is I'm going to need to multiply each of them by something so that I do have matching coefficients of x or matching coefficients of y. For matching coefficients of x, I would multiply 5 and 2 together to make 10, but that involves multiplying this second equation by 5. It's going to be easier if I make the y coefficients match. I can make them both equal to 12, well I can make one negative 12 and one positive 12. So I'm going to multiply equation 1 by 3. And I'm going to multiply equation 2 by 2. And this gives me equation 3 and equation 4. And what I can do from there is this time I will add them together because the signs for the variables with the same coefficient are opposite. So if I add them together, so if I do 3 plus 4, I will get 15x plus 4x is 19x. I'll get negative 12y plus 12y is just 0. And then 69 plus negative 50 is 19, which means that x equals 1. Then plugging that into either of the original equations, 1 or 2. I'm going to plug it into 2 because I think that's slightly easier. That equation now becomes 2x, but x is 1. Plus 6y equals negative 25. Then we get that 6y equals negative 27. And then y equals negative 27 over 6, which is negative 4.5. So now I would like you to have a go at questions 2 and 3 from the exercise on Show My Homework. You can see most of them on the screen underneath the example, but you will need to go and Show My Homework for the rest of question 3. So have a go at those, please, and then mark your answers, and then we'll go on to the final example for today. So you should now have had a go at the questions from question 2 and question 3. If you haven't had a go at those yet, please pause the video and do those now. Otherwise, I am going to put the answers on the screen. So these are the answers. Please make sure you've marked your work, and then we'll go on to the last example. Our last example for today is still linear simultaneous equations. We are going to do quadratic simultaneous equations in our next lesson. So copy this example down, please. Pause the video to do so, and then let's get started. So these are this is a wordy example, and then you're going to do some wordy questions, which is where you have to set up your own simultaneous equation. So let C be the number of chairs, be the price of a chair, and let T be the price of a table. So I'm defining the variables because I'm going to have to make up my own simultaneous equations, and so if I'm going to use variables in them, people need to know what they are, what they're representing. So for Sue's purchase, we can turn that into 4C plus T equals 142. And for Ken's purchase, we can turn that into 6C plus 2T equals 254. So 4 chairs plus 1 table costs 142. 6 chairs plus 2 tables equals 254. Why Ken wants 2 tables and only 6 chairs, I don't know. You're only going to have 3 at each. Doesn't make a lot of sense, but, you know, it's Ken's money. He can do what he likes with it. From here, we want to identify how we can manipulate one of the equations to make the variables have the same coefficient in each equation. So the easiest way to do that is we've got 2t here and 1t here, so let's do equation 1 multiplied by 2. So now we've got 8c plus 2t equals 284. And I'm going to write the other equation underneath it. So this is equation 3, this is still just equation 2, and we're going to do 3 minus 2. So we end up with 2c equals 30. And that gives us that c equals 15. It's going to be easiest to plug that back into equation 1. So 4c, 4 times 15, plus t equals 142. Gives us that 60 plus t equals 142. And so that gives us that t equals 82. So now let's just write a concluding sentence. Therefore, the price of a chair is £15. The price of a table is £82. So what I would like you to do now is have a go at the questions from exercise 2. I have missed out a few of them, and I'm going to put the ones I want you to do up on the screen as well. Make sure you have paused the video and copied this example out, please. So I would like you to do questions 1, 2 and 3. So there are the answers. Please mark those and then upload your marked work to show my homework, please. Thank you.